So our next session before lunch, we're going to talk to the Kubernetes core team. This is many members of the founding team as well. If you guys could take your prima donna selves and sit down. So what we're going to do while they're getting started, we're going to ask a few canned questions. Trust me, I'm going to try to ask some very challenging questions, and then we'll open it up for Q&A. So I'm going to place the mic here, and you can come up and ask your question, and they'll answer it. Oh, and now that I have them, they can sign these Kubernetes up and running books. So if you're still paying attention to the competition, you will win these. So sign and pass. You have to sign 2 books and pass across.
Let's see if we can talk and...
Now these will probably have 0 value on eBay, but you can attempt to put them there. I will probably bid them up myself to gain a few confidence points. Now we're going to start introducing ourselves from left to right. You have your mics. Sure. Just introduce yourselves and go from there.
Yeah, I'm Joe Beda. I was one of the founders of Kubernetes along with Brendan and Craig. Yeah, so we put together sort of the plan for the project and got the first version. But honestly, I think we were all stunned with sort of where things went from there. So.
Hi, I'm Tim Hawken. I'm one of the early people on Kubernetes. I didn't quite bootstrap it, but I jumped on as soon as I saw what it was and got involved. Before this, I was working on Google's internal system perspective that we bring to it.
Hi, I'm Brian Grant. Like Tim, I previously worked on our internal systems, Borg and Omega, which was a project that I helped found. We started working together with the cloud teams, which is where Joe and Brendan came from, the internal infrastructure and cloud married together. So we were trying to apply our expertise from our internal infrastructure systems to things that we could build that would directly benefit our cloud customers. And that's really what the origin of Kubernetes was.
Hi, I'm Daniel. And like Brian and Tim, I came from Google's internal system. Shortly after Tim joined the project, I came along and yeah, now I'm Lava Lamp on GitHub.
Cool. You just put it underneath the table. I'll grab it. So cool. So I'm going to open up the first question. This will be an easy one. So you guys can take turns here. So why Kubernetes? Why build source? I assume it was so easy to make this thing open source once you came up with this fantastic idea.
That's right. We didn't spend months convincing people that we should do this, or quarters. Why do it? You know, this is something that some of us have wanted to do for a long time, talk more. We do. When Docker landed about 2 years ago, 2.5 at this point, we sort of saw it as the beginnings of coming towards the Google way of doing things, and we wanted to be involved. I mean, I'll speak for myself. I wanted to be involved. I wanted to help shape the conversation. I feel like we've got a lot of battle scars. I feel like you all needed to earn your own copies of those scars. And so we thought we'd bring some of our experience.
So yeah, so I think actually it started a little bit earlier than that. I helped start Google Compute Engine, and believe it or not, Compute Engine was a little bit controversial inside the company because a lot of folks inside of Google, after they had experience building stuff on top of Borg, felt like VMs were really moving in the wrong direction. And so but it was clear in terms of sort of hitting the market and building a product that would have wide appeal, you needed a VM product to actually sort of play the game. But there was always a little bit of a feeling on my mind that sort of VMs were a little bit of a stepping stone to the next thing, based on our experiences at Google. And then as Google got more and more serious about cloud, Compute Engine is built on top of Borg, but asking internal teams to start managing VMs really felt like a step backwards, right? When you're used to dealing with these higher level container concepts and all the stuff that you see in Kubernetes, saying, hey, you should go back and manage VMs and sort of own everything that happens inside the VM, it seems really, really strange. And so getting both Google internal and on the same page really was about sort of moving everybody forward to the next thing. And so that was one of the big justifications for Kubernetes.
Yeah, and as I mentioned before, we really wanted to take this internal experience we had running things on Borg and transfer that to could use especially our cloud customers, but really everybody. This is sort of a sea change for the industry, and we wanted to help make that happen.
Cool. So this has been an interesting topic. There's been a lot of debate regarding the difference between orchestration, kind of things you see from Alt, and automation. It said that Kubernetes eliminates the need for orchestration. What does that mean? And could you go into any detail there?
Yeah, I can take that since that's my text that you're reading. There's sort of a narrow definition of orchestration, which is to execute a defined workflow. So do A, then do B, then do C. And that's really the way people start. You know, when they do things by hand, then they want to script that. Then they want to make that a little bit more robust using maybe a workflow tool. But really, to go to the next level, you have to deal with things like, well, what if something happens in the middle of that sequence of operations? Or what if, you know, some dependency that this workflow depends on is not satisfied? Or, you know, any number of different scenarios can happen. So when you actually want something to automate in a robust way, you actually need a different set of primitives to build on than this narrow definition of orchestration. Also, you know, these workflows can get very complex if you build them up as a tree of operations. Like, really want to break it down into pieces that are independent and resilient and can operate on their own. So Kubernetes was really designed for this pattern to be able to build these robust automation systems, and that can be scaled up both in terms of the number of things that you're doing and also extensible, so people can add whatever automation they need to the system and actually just run it on top of Kubernetes and extend the functionality by doing so. So we use a pattern extensively that is sometimes called choreography, which allows, instead of a centralized controlling the sequencing of everything that's happening, these control loops can operate completely independently, and you can add more control loops to the system that don't directly have to understand the other control loops. They just, each one fulfills a narrow responsibility. And that's really what we're trying to achieve with Kubernetes. Kubernetes provides a discrete set of functionality to help you manage application, as Carl talked about in the previous presentation. Things like replicating your container or scheduling your container. But it's also a platform for building these kinds of things. And our components themselves use the Kubernetes APIs, and you can build things that use these APIs to build more of these things for your specific workflow or scenario that you need to automate.
Yeah, I think just to expound on a little bit of what Brian was saying here, I think, when you think about it, orchestration, it's orchestra, you have a conductor, you have a score where everything's out. But, computers these days, and especially distributed systems, don't work that way. We all like to, envision that we live in a world where computers are deterministic, but especially with distributed systems, you get emergent behavior. You have this idea of weather, where you have flows of users coming, failing. You have these random inputs that can't be scripted and can't be planned for ahead of time. And so, choreography is one term. I actually think jazz improv is probably a different way to think about it, right? Where it's like you have sort of a set of rules and you have a direction that you're going, but you can't plan everything. You have to have intelligent, smart systems that actually sort of help move you towards the direction you want to go.
Awesome. So here's the next question. So there's been a lot of debate regarding the scalability of Kubernetes. For example, Kubernetes is limited to 100 nodes. Or Swarm can schedule like 1 gazillion number of IPs and IPv6 containers per second, and Kubernetes can't. What comes to mind when you hear these things from the community, and can you kind of address that?
I don't think a gazillion's a real number.
It is on the internet, so it's true.
I mean, scale is important, but it's not a goal of itself, right? I mean, the goal here is what can you do with scale? What do you need to do with an application? And it's great to say I can support a gazillion, trillion, whatever that number was. But is it useful? Do you need containers? Really? I mean, you can do a whole lot with a couple hundred. Now, I think we are past the point of Kubernetes supporting 100 nodes. I think perhaps the Kubernetes team made a tactical mistake here. We sort of relied on our very rigorous definition of the word support. People would resonate with just how rigorous that was and what our SLA was about support. But I think most people just saw the number. And so I think we can move past that and say we actually support quite a lot more than 100 nodes. What do we make our SLA guarantees about? Well, that's a different question, right?
Yeah, and so we have been working on scale. We actually chose explicitly not to focus on scale at the beginning because we want to get some of the more fundamental concepts out, make the system, start with something that's usable from day one, and let people get experience and try to understand it and take their feedback and iterate. So and we knew from that we could make it scale arbitrarily. We know how to do that. We run systems at very large scale, and Joe presented over a year ago that we launched 2 billion containers a week. Yeah. So that's just a mere matter of programming. I've had people run clusters up to at least 1,000 nodes, and with 1,000 nodes, you can run tens of thousands of containers. So we'll be making that run better and better, meeting our rigorous SLOs over time. But as Tim said, the real with it, and there are a very large number of people who don't need thousands of nodes and can do very interesting things at much smaller scales, or you can scale out in different dimensions, for example, with multiple clusters, because people actually want multiple resource pools in different zones or different regions, or on-prem and in the cloud. So necessarily be managing thousands of nodes or 10,000 nodes as a big monolithic unit, but in sort of smaller pools. So we're building in that direction, and we'll get there.
Cool. And I guess for the people in the audience, what is the Google SLA around when we say 100 nodes are supported? What does the SLA mean? I think a lot of people have that question.
So, I was talking to Tim just before we came on here, and he was talking about how he goes to a user group and he demos Kubernetes, and a lot of times he'll type in a command, and by the time he can start talking about it, that thing's already done, right? And so, Google holds a very, very high bar internally in terms of the quality and the speed at which you can do things. In the early days of the company, whenever you'd present a product to Larry or Sergey, if it was taking then a few seconds to actually have a web page come up, Larry would start humming the Jeopardy theme, right? I have no sense of tune, but so there's this real focus on latency and on speed, right? And so I think for us, we want, if it takes 2 minutes to do something, that's too long. And so it may be possible to do things at scale and have it take longer, so technically it works. But for us, we really want to bring things back down into that interactive space.
Yeah, I would say specifically for our current SLA is service level agreement. We expect all API operations to
There's nothing more frustrating than running a command and having to sit and wait and wait and wait and wait for it to complete, right? So I think we set our goal as 99% of our API operations complete in under a second.
Yeah, it's not just user commands that we care about. Commands that really matter. That's where like the
scheduling decisions.
Yeah, scheduling decisions, replication controllers decisions. That's where the last few nines really matter.
So one question that some people have in mind, me included, if Kubernetes wanted to replace Borg, what would need to happen in terms of feature quality? That laugh should tell you how many Googlers are actually here.
Borg does like 8,000 things. Borg has 10, 12 years of saying yes to all comers in terms of, so I think it's not what would Kubernetes have to do to switch from Borg, it's what would Google have to do to switch away from Borg. And I think a lot of it would be letting go of sort of vestigial features that aren't really that useful anymore, moving away from mindsets where they have too much control, and moving where you sort of let the system control a little bit more, let the system drive. I think that is the bigger problem, not adding features to Kubernetes, but taking stuff away from Borg.
I think with Kubernetes, we made an explicit choice to design for outside of the community, because Google has a bunch of weird requirements, and we don't want to rebuild them. So.
Yeah, and Google also internally has a vertically integrated stack, and we control the entire ecosystem from the kernel on up. And we have compiler developers, we have kernel developers. We build all of our applications from scratch. We don't use any of the same applications outside of Google. So, you know, Borg, if you squint, has a lot of similarity to Kubernetes and vice versa, but it differs in a huge number of details. So, for example, you know, Borg predates Docker by a decade. So, you know, switching Borg-style containers to Docker-style containers would be actually a huge switch, massive shift.
Yeah,
cool.
Not to mention the config lines that we have in our.
Yeah, we have millions and millions and millions of lines of configuration files, right? So changing all of those, millions and millions and millions and millions and millions of lines of code built for the Borg ecosystem is just something that would take a long time if it even made sense to do.
Yeah, if it was just configuration files, it wouldn't be so bad, but then people write tools to generate their config files, and you have to go fix all the tools.
Well, the config language is Turing complete, so.
Yeah.
So cool. If you have questions here at the invisible microphone, there will be one there soon. We have a couple more questions before we take questions from the audience. Now, if there was one thing you could change about Kubernetes, well, hold on. Before I ask that, so I don't know if this is the first time many of you had to actually work with the community on such an important project. To get like feedback, what has that experience been like? Challenges, and I guess the good parts.
I think it's really exciting to work with people outside of Google, and the volume of PRs and the time and effort people have been putting into this have been really fun to watch, and it's been a great experience.
Yeah, I have to second that. It has been a really great experience working with the community, building something with the community, and also getting immediate feedback from people who use the system. It is really a very different interaction model. It's sort of internally within Google, effectively all of our source is open source, and everybody can build the code and see the code. You know, but not that many people take Borg and run it themselves. Mostly it's run as a centralized service. So, so that's been really different in Kubernetes. In terms of what's been challenging, just the volume of all of the PRs, the issues, the support requests. I mean, we want to help everybody, and we want to help everybody be a successful contributor to the process, successful user of the system. But it's just really, really hard to keep up with the volume.
I mean, I don't want to say all the same stuff, but I learned to code open source. So it was where I really got involved in programming, getting involved in Linux and early versions of Red Hat, and that's really where I fell in love with programming. And then I went into Google, and I sort of was working in the kernel for a while, and then fell down the Google rabbit hole of internal systems, and I spent years and years doing that, and I came out the other end, and oh my God, the world is different. Open source today with GitHub, everything being webby and cloudy is so very different from the days of SourceForge and CVS, and the Go ecosystem is so radically different from the C ecosystem, if you can say there is one. So this has been a huge change for me, but it's so invigorating. So much fun working with people, talking to people. So many great ideas have come from all the people in this room of things that we never would have done that turn out to be like the most fantastic features in Kubernetes. I like to pick on namespaces as something that we just don't do inside Google that we would probably not have invented in Kubernetes in nearly the same form. But thanks to the power of open source, the Red Hat guys came and said, we really want to do this. They pushed on it. And it turns out it's actually one of the most cool things in the system.
Kube control is a great example also. Yeah.
Yes, yeah. The things that we can accomplish with open source that we could never do internally. We have plus unique contributors to Kubernetes, right? Only 40 of those come from Google, right? The rest are out here, I hope.
For me, I mean, so I spent most of my career building platforms and actually talking with customers at Microsoft and then at cloud at Google. And it's been an interesting about sort of dealing with the public, right? In terms of like from a customer type of thing where there's always a little bit of a gap there in terms of responsibility to actually starting to deal with people as peers and as contributors, and that's actually been really, really great, right? I feel like it's a much more honest interaction when you're dealing with somebody as a contributor versus actually having that sort of that customer interface. I was expecting that there would be problems as we did this stuff around people wanting to take Kubernetes in a direction that we thought was just the wrong direction. And I'm really glad to say I don't think that that's happened. I think that it's been really gratifying to see just mostly the community get it. I think they understand sort of what we're trying to build, and we've had a lot of substantive discussions, and I think there's been a lot of great ideas flowing both ways. And so that was something that I was problem, but ended up not being a serious problem at all.
I think one of the things we put in place early on was this idea that we knew we didn't have all the answers. We knew that things that we'd done inside Google in the past weren't always going to apply, and that we sort of came into it with a very open mind. And I think we still keep an open mind. So if you have a great idea, please send it to us, but maybe not this week.
Or you know, PR is welcome, right?
Yeah, that's right. Issues that come with a patch get reviewed much faster than issues that don't.
Cool. So I think one thing a lot of people talk about are the concerns of Kubernetes becoming OpenStack. You all say it, I just regurgitate here. So I think one of the things with OpenStack, to clear that up a little bit, is that when OpenStack came out, it came out as a clone of another service. So the thought leadership in that begin with OpenStack was just a clone of something else. And the something else wasn't necessarily on board with the clone. So now you have Kubernetes. How does Kubernetes preserve its identity and continue to grow a community around it that doesn't get taken in 1,000 directions that are not necessarily technical?
Well, I think one thing we have to do is we have to make sure that there's a core that works pretty much everywhere, right? And I think just instinctively we've sort of been heading in that direction. I don't know if it's been an explicit decision there. I think doing a thorough sort of honest analysis of sort of where OpenStack is at is probably beyond the scope of this panel, and it probably isn't, we're not the best people to do that. But I think, that's one thing. I think another thing is that, making sure that, the people who are actually making the decisions are the ones who are writing the code and using the system in production, right? And so, we're happy to have vendors come and play, but we want to make sure that it's not sort of just throwing code over the wall and then now it's our problem, right? We want to make sure that we actually have something that continues to hang together as we move forward. That's sort of a common value of the set of committers and the set of contributors to the project.
Yeah, and we were discussing this earlier with Clayton as well. I'll pick on him since he's sitting in the front row. And he threatened to pick on us, but he hasn't yet. We do want to have this core and to have conformance test to validate that deployments of Kubernetes actually conform to the spec of that core. But we also want the system to be extensible, like I talked about before. So as long as it's easy to deploy those extensions onto a running Kubernetes cluster, then if someone depends on one of these extensions, it's easy for them to deploy that extension.
One of the hardest things we have to do is say no to people, right? Lots of people come in with really great ideas, and I think the most powerful phrase that is in our vernacular right now is, what are you going to do with that, right? What are people going to do with that? What problem? And I ask this question of a lot of people, and it really helps me to sort out the I'm pushing an idea because it sounds neat from the I have a real problem and I want to scratch my itch. And so being able and willing to say no to people in a polite, well-meaning way, and hopefully or to rethink some of their ideas is a big challenge that we've got. And we need to maintain sort of civil discourse as we tell people that they're wrong.
But I think, it's not necessarily you're wrong, but it's like, oh, if you want to solve this problem, here's some other ways that we might think about solving this, and just go through that thought exercise. At the preconceived notion that we have with how to solve a problem doesn't quite fit that, and so everybody has to move in the right direction. So instead of starting with the solution, being able to backtrack and actually start with the problem and understand how to best.
Yeah, that's really important for us also, both to really problem the person's trying to solve, but also to take into account that the way we would solve the problem won't necessarily work the same way outside of Google that it does inside of Google. I mean, I sometimes say that depending on how I'm feeling, that I have a 5-year roadmap or a 10-year roadmap or whatever for Kubernetes in my head based on things I've done in the past. So generally for any given topic, we have some idea of what we would do for that problem, but it might not 100% fit the way the users of Kubernetes actually need it to work.
And from a purely technical point of view, just my last point, we have this problem that we have to thread the needle between writing APIs that are so generic that they're not useful for anybody, and writing APIs that are so detailed they become the superset of every other API, and half of the features don't work on every platform. And there's really no recipe book for doing this, right? It's 99% perspiration, poring over the use cases, and coming up with ideas and scribbling stuff up on the whiteboard and throwing ideas around and writing a doc that you then throw away because you were completely off base in the first place. And we're gonna make mistakes. We've made mistakes. We'll make new ones.
Yeah, we're gonna work towards making it really easy to experiment with new APIs, to shard the development process for these and really figure out what works and what works well together and what we can upstream.
All right, cool. So we're going to take a question from the audience, and you're the only one because you only want to. Look at that. 2. That's it.
All right. I see somebody else back there. Oh, no, he's just sitting down.
2.
No.
We're going to do these last 2, and then we're going to close lunch.
I just feel terrible for Kelsey to having to ask all the questions. So there's lots of people who do lots of things in lots of different ways already, right? And so I was wondering if you have any advice for people who have kind of a brownfield environment. What's a good way to get into Kubernetes? How do you migrate, from what legacy infrastructure to either using Kubernetes as a component of what you're doing, or migrate as much as you can into it? What are your thoughts on that?
Well, I mean, to some degree, you're asking the wrong people, just to be honest, because I think, I left Google recently, and deprogramming that has to happen when you leave Google, right?
I don't know.
Yeah, you wouldn't know. But, I mean, I think the right way to start approach this, and it's the same sort of thing when you start talking about sort of how do you actually start using cloud, right? How do you actually start changing your infrastructure and adopting new methodologies? I think the first thing to realize is that no application is an island, right? Everything sort of has connections to other parts of your organization. So I would suggest start with a small project, maybe an internal tool, an admin interface, something like that. Experiment with running that on Kubernetes, get comfortable with it. And then as you sort of refresh parts of your infrastructure and touch stuff, kind of like, building something up to code when you actually do a renovation of your house, right? As you actually start touching that stuff that you haven't touched for a while, then say, okay, is it now time to actually bring that, up to code and actually start using these new techniques that we're now comfortable with? Don't start by saying we're going to rewrite everything. That rarely works.
I think the other big shift that we've seen is actually moving from kind of statically assigning applications to hosts to the dynamic scheduling. That's really the shift that causes you to have to throw away all your host-centric infrastructure and move to all container-centric infrastructure. So if you want to benefit from some of the tooling and some of the mechanisms in Kubernetes, you can start by doing that manual assignment. Kubernetes actually allows you to assign pods to nodes. So you can assign pods to nodes, you can use host network, you can use host ports, and you can use that as a bridge from your host-centric world to container-centric world.
I put out a challenge to anybody here, right? If you're building out your framework or your infrastructure, and you want to use Kubernetes, and you find that you found a step that is just too big to take in one step, I want you to call us on that and talk to us about it, because we want to build the bridges between the old world and the new world, and we've got dozens of them in the system, dozens of affordances that are here specifically to help people who have existing infrastructure move onto it. Even if they're sometimes not the best practice, we understand that they're part of the process. And if you run into a wall that should be a staircase, I want you to let us know, because we need to fix that.
Hey, so where I currently work, we have a versioned and declarative infrastructure, and while we're rolling out the Kubernetes system in dev, I've encountered that Kubernetes doesn't really work that way, and just wanted to get some thoughts to adapt something like, your infrastructure is 100% declarative in a Git repo, and having that work in the Kubernetes world.
Yeah, so we're actually in Kubernetes 1.1 have built a new mechanism to kubectl called apply. So you can now say kubectl apply. And that will actually take the resources you have locally, and it will reconcile them and diff them with the live state and update just the parts of the live state that need to be updated. So you can actually fully declare your application, the application resources that you need, and then make it so on the Kubernetes side.
Yeah, I really think you should keep you should keep all your config checked into source control somehow.
Yeah.
So, but we're out of time. But if you want to discuss it later, I mean, come grab us and talk.
What is the room? Presidio?
Presidio. We've got a room upstairs where we'll mostly be hanging out for the afternoon for people who want to come in and have their PRs shot down in person.
All right, so with that, it's almost time for lunch. Lunch is upstairs. Be sure to see all the sponsors. Thank you.